Hello students. So chemical reactions and equations. This chapter is very important to understand what exactly is a chemical reaction, how to write a chemical reaction. To start the discussion students, first of all answer what is a chemical reaction in the name directly the heading itself. What is the meaning of a chemical reaction? How can you define a chemical reaction? First of all, to define a chemical reaction, you should know a chemical change. What is a chemical change? For example, when ice melted into liquid water, is it a chemical change? Like, is there any reaction taking place? Student, the answer is no. That change is called as a physical change. That change is called as physical change. In the next example, when salt is added to water, what happens? When salt is added to water, like the salt gets dissolved into the water, yes or no? Is there any new substance formation takes place there? No, still salt is there and still water is there. Understood? Simply they mixed physically. So that change is a physical change. Then what is a chemical change? In another case, rusting of iron. We all know that iron particles over the long use or the long exposure to the moisture, they converts into brown color coating. Yes, sir, students. What is that? Is that change a physical change or chemical change? That change is a chemical change. Sir, why color changing called as chemical change? No, not just because of color change, because of chemical composition is changing. What happens, students? Chemical composition is changing. Initially iron is there, now iron becomes into iron oxide. Initially Fe is there, iron symbol is Fe, it became into Fe2O3. Formula is changing or not? Then that change is called as chemical change. One more example, hydrogen gas reacts with oxygen gas, produces H2O, water. H2O2 gives rise to H2O. Now answer, is it a physical change or chemical change? The answer is it is a chemical change. Why? Because hydrogen gas H2, oxygen gas O2 combining to produce water H2O. Chemical formula is changing or not? Then that change is called as chemical change. Then what is a physical change? Anything can change. Physical state will change, densities will change, color changes, but the chemical formula remains same. When ice converts into water, does the formula of H2O changes? What is the formula of ice? H2O. What is the formula of water? H2O. What is the formula of water vapor? H2O. Is the formula changing? If the chemical composition is changing, if the chemical formula is changing, that change is called as a chemical change. In this topic, why we have the discussion about chemical change? The reason is, students, the representation of this chemical change. What is that? The representation of this chemical change is called as chemical reaction or chemical equation. What is that? The process and the representation of the chemical change which is happened called as chemical reaction. That's it. Yes, sir. Now, for example, we are saying hydrogen gas reacts with oxygen gas, produces water. You want to represent it, H2 hydrogen gas formula plus it is reacting with oxygen gas O2 formula, and both are reacting producing H2O, gives rise to H2O. This is called as chemical reaction. So how can you define a chemical reaction? There is representation of a chemical change is called as chemical reaction. Understood? Got the clarity, students? The representation of a chemical change is called as chemical reaction. So here, students, in this chemical reaction we have an introduction. So the transformation of chemical substance into another chemical substance. Yes, sir, I said clearly, during the chemical changes what happens? A new substance formation takes place. Sir, why new substance? Chemical formula is changing, na? That's why new substance. Yes, sir, no. So the transformation of chemical substances into the another chemical substance is known as chemical reaction. Chemical reaction we can define in n number of ways. Reactants react, produces a new product, chemical reaction. Breaking of bonds, formation of new bonds, chemical reaction. When two components are reacting, produces a new substance, chemical reaction. N number of ways we can define a chemical reaction, students. Ultimately, what is happening in the chemical reaction? Some components are reacting, they're producing a new substance. That new substance has a new formula. A chemical formula has its own formula. Yes or no? That means the formula is changing or not? That is called as a chemical change, and the representation of that change is called as a chemical reaction. So for example, we have the examples given here. Rusting of iron, like I said, iron converts into iron oxide. Setting of milk into curd. Yes or no, students? Milk to curd, is it Is it a chemical change or physical change? Milk is liquid, curd is like semi-solid. Is it a physical change? No. Chemically it is changing, students. Which is good for digestion, milk or curd? Curd is good for digestion. You know what is happening? The bigger protein molecules break down to form smaller protein molecules which are easily digestible. That means molecule is breaking or not? If the molecule is breaking, the formula is changing or not? That's what. So milk, conversion of milk into curd is also a chemical change only. Digestion of food. Yes sir, all the food particles are digested, converts into calories, energies, everything. Breaking down only. It is also chemical reaction. Respiration, right? Taking oxygen, giving us, releasing carbon dioxide. Photosynthesis, taking carbon dioxide, releasing oxygen gas. These are all chemical changes. Definitely we need to represent that change or not? To represent, how to represent? Chemical reaction, right? We can represent, that representation is called as a chemical reaction. So in chemical reaction, new substance is formed which is completely different in properties from the original substance. So in the chemical reaction, chemical change is taking place. This point is very, very, very important, students. For example, iron oxide, right? Iron converts into iron oxide during rust. So iron oxide, iron both are same? No. Yes or no? The new substance has its own properties, right? Iron is a solid metal, right? Iron oxide is a flaky substance. It's a powdery substance, right? That's what. Hydrogen is a gas, oxygen is a gas. When they combine, they produces liquid water. It's a completely different or not? Sodium chlorine combines to form sodium chloride. Sodium is a highly explosive metal. Chlorine is used as a disinfectant and it's a poisonous gas also. When they combine, they produce sodium chloride. Where do we use sodium chloride? Is it explosive like sodium? Is it poisonous like chlorine? We are simply using sodium chloride in cooking or not? And that's what the point says. That means a compound after the formation of the compound, it doesn't have the properties of its reactants. It doesn't have the properties of its reactant. Why sir? Why? It's a new compound, right students? It has its own chemical properties. It has its own formula. It's a completely new substance. Understood? Got the clarity? That is called as a chemical reaction. So let us consider two processes. We have in the given examples, dissolution of sugar into water and cooking of food. Dissolution of sugar into water, like in the beginning in the example I gave, add salt into water or sugar into water. Is it a physical change or chemical change, adding sugar into water? Is there any chemical composition changing? It is still called as sugar water. Yes or no? Sugar is there, water is there. Are they reacting to produce any new substance? No. Sugar molecules are getting into the spaces between the water molecules. That's it. Understood? This is a physical change, not a chemical change. For physical changes, can we write the chemical reaction? No. Representation of chemical change is called as a chemical reaction. So cooking of food. Cooking of food means, like in the previous slide also we discussed, breaking down the molecules. So that is a chemical change. For example, hydrogen gas combines with chlorine gas, produces hydrogen chloride, HCl. Look at this reaction, students. Here hydrogen combines with chlorine, produces hydrogen chloride. Yes or no? Is this a physical change or chemical change? With all this knowledge, you can easily say this is a chemical change. Why? Because hydrogen gas reacting with chlorine gas, both combined, they produce a new substance. That substance is HCl. Now, the crucial point. Does this HCl molecule, does it have the properties of hydrogen? Students, does this HCl molecule, does it have the properties of hydrogen? Yes or no? The answer is no. Does it have the properties of chlorine? Sir, chlorine is there, so it behaves like chlorine. The answer is no. It is a completely new substance. It has its own properties. Sir, properties means what? Everything. Physical properties and chemical properties. It has its own melting point. It has its own boiling point. It has its own densities. It has its own color, taste, order, shape. It has its own chemical reactivity also. How it reacts with water, how it reacts with oxygen, how it reacts with any other chemical. It's a completely a new substance, students. So this is a representation of a chemical change. Understood? Got the clarity? So one crucial point is, under the chemical reactions, a new substance is formed, right? So reactants and products, right? Correct. So like I said, a chemical reaction takes place by reacting some components and producing a new component, right? Some components are reacting, right students? They are called as, look at the side heading here, reactants. What are reactants? Substances which take part in a chemical reaction are called as reactants. Next, a new substance is produced, right? That is called as product. reacting, that means molecules are reacting. A new substance is produced, that is called as product. New substance formed after the chemical reaction is called as product. For example, look at here, carbon plus oxygen gives rise to carbon dioxide. Now what are the reactants here, students? In this reaction, what are the reactants? Carbon and oxygen are reactants. Why? Because they are reacting. Yes or no? These reactants we have to indicate before the arrow. These reactants we have to indicate before the arrow. Why? Because they are only reacting and they are producing a new substance. That new substance is called as carbon dioxide. Now which is the product? Of course carbon dioxide is the product. Got the clarity? Look at here. Are we representing the reaction using the names? No, we are representing the reaction using symbols. Look at, carbon is C, oxygen gas is O2, gives rise to, what is the formula of carbon dioxide? CO2. C plus O2 gives rise to CO2. What are the reactants? C plus O2 are the reactants. What is the new product? CO2 is the new product. Got the clarity about the reactants and products? The components which are reacting are called as reactants, and the component which is getting produced in the reaction is called as a product. So characteristics of chemical reactions, some of the main points what we can see in these reactions, students. First of all, change of state. During the chemical reactions, physical state may change. Sometimes change, sometimes may not change, but that can be seen under the reactions. Understood? State means physical state. What is the physical state? Solids, liquids, gases. Solids can be converted into liquids, liquids can be converted into gases also, but ultimately what is changing? Formula is changing. Remember, hydrogen, same reaction given. Hydrogen is a gas, oxygen is a gas, water H2O is a liquid or not? A new substance is getting produced and that new substance is a liquid. Got the clarity, students? Gases converts into liquids. So change of state will happen. Not every time. Sometimes happens, it depends upon the type of reactants, right? Next, evolution of gas. Under the reactions, of course, change of state means gas also comes under the three states, right, students? So gas can also be produced. So sodium students, sodium is a metal, solid, right? H2O is a liquid, right? When sodium is dropped into the water, what we can get? Sodium hydroxide, NaOH, and we'll get hydrogen gas, students, H2, hydrogen gas. A gas is produced or not? So chemical reactions can also be characterized by evolution of gases. That means gases can also release under the reaction, right? So a solid is participating means end up with solid only. No, not every time. Not every time. It sometimes they converts into liquids. It depends upon the characteristics of that new compound, new product. It can be exist in liquid or gas or a solid also. Next, change in color can also be expected under chemical reaction. For example, students, like rusting of iron is the best example. Iron is a silvery metal, yes or no? If you cut the iron, you can see the inner part. It's a silvery metal. Rust, what is the color of rust? It's a brown coating will appear. So silver to brown color, yes or no? Statue of Liberty, it's a copper. You know copper color, brownish, shiny color, yes or no, students? But what is the Statue of Liberty color right now? Pale, bluish green color, yes or no? Why? Because why the color is changed or not? Nobody know the previous color. They are all thinking like that is the original color. No, that is because of corrosion. That is because of the formation of copper carbonates and copper hydroxides. Understood? Got the clarity? Under the chemical reactions, colors will also change, right? Look at here, silver. We all have silver ornaments at home, yes or no, students? Once ask your parents also, over the long use, how the silver changes its color? Is it changes to red color? Is it changes to blue color or black color? Silver changes to black color. Not completely. The edges, the corners becomes black. You know the reason why? The reason is because of a chemical reaction, students. Silver reacts with hydrogen sulfide and oxygen. It produces silver sulfide plus H2O. This compound is the reason for the black color. Which compound? A new compound or not, students? Initially silver is silver in color. It converts into black color. Sir, why it is converting into black color? Only color changing? No. The compound is changing. That's why color is getting changed. Understood? If the compound is changing, it's a chemical reaction. Iron is silver, but rust is brown in color. Understood? So under the chemical reaction, students, colors will also change. Next, temperature changes can also be expected. Chemical reactions mainly happens by two ways, students. by releasing energy, by absorbing energy. Releasing energy called as exothermic reactions, absorbing energy called as endothermic reaction. So when water is added to quicklime calcium oxide, the mixture becomes hot due to the evolution of heat energy. CaO plus H2 gives rise to CaOH taken twice, plus it releases some kind of energy, exothermic reaction, students. So got the clarity. Chemical reactions are also characterized by absorption or release of heat energy. For example, students, after the lunch, after the breakfast, have you observed after like half an hour or 1 hour time, we will become little warm. Yes sir, our body becomes little warm. Why? Because digestion is an exothermic process. It releases some energy. That's why what our grandparents and parents, what do they say? Don't go to bath after eating. Yes sir, no. Why? Because of the sudden loss of, if you wash your body, that temperature, if it is suddenly cooled down, it slow down the process of digestion, which is not good for our biological activity. Understood? So ultimately the point is, chemical reactions are characterized by loss of heat energy, not every time loss, gain of heat energy also. Change in order, smell also. Best example, every time the food getting spoiled, yes or no, everything. If it gets spoiled, we get a bad smell. Sir, why we are getting that bad smell? Because that compound is giving that smell. That compound is giving that smell. Due to the chemical reaction, food gets spoiled and the smell really bad. Look at apple or bread. Look at this spoiled bread and apple. What is happening? Decomposition is happening. Fungus, viral growth is happening. Yes, sir, students. That leads, sir, what is happening? In new reactions, new chemicals are getting produced, and these chemicals are releasing that smell. Understood? Next, formation of precipitate. Precipitate means, students, insoluble solid is called as precipitate. So some chemical reactions are characterized by the formation of precipitate. A precipitate is a solid product. It's a solid and it is insoluble. A solid product which separates from the solution during a chemical reaction. For example, chemical reaction between potassium iodide and lead nitrate is characterized by the formation of an yellow precipitate called as lead iodide. Lead, PbI2, lead iodide, students, is a precipitate. It is yellowish in color. So chemical reactions, during the chemical reactions, precipitate formation also possible. Precipitate means what? Some insoluble solids can also be produced. So what are all the points we have seen under this reaction, students? A change, physical state may change, yes or no? Color may change, odor may change, yes or no? And precipitate formation takes place. Temperature may change. That's it. These are main points. Ultimately, what is the main point? Chemical formula is only changing. That's the main point. If physical state changes, color changes, order changes, everything changes, if the formula is not changing, can we call that as a chemical change? No. When we have to call it as a chemical change? If the chemical formula also changes, then only chemical change. Understood, students? In addition, color may change, order may change, everything may change. But what main point is? Formula. A new substance is getting produced. Next, chemical equation. Right, I already have said. Symbolic representation of a chemical reaction with the help of symbols and formulas. So, a chemical reaction is characterized by the reactants and products, right? And how to write that reactants? By the name? No, it has its own symbol, it has its own formula. That is called as, that shortcut representation of this reaction is called as chemical equation. So, for example, A reacting with B producing C and D. How to write the reaction? A plus B gives rise to C plus D. This is called as chemical equation. Yes, and the representation of that change of the reaction is called as chemical equation. These chemical equations are mainly two types, students. One is called as balanced chemical equations, other one is called as unbalanced chemical equations. I'll give you the clarity. Listen. Balanced chemical equations means, students, listen. In the nature, everywhere, all the reactions are always balanced only. So then why unbalanced? That clarity I'll give you. First of all, let us discuss what is the meaning of balanced chemical reaction. Balanced chemical reaction means, students, the number of atoms which are participating in the reaction are equal to the number of atoms which are produced in the reaction. That's it. Sir, no, obviously the number of atoms which are participating in the reaction are equal to the number of atoms which are produced in the reaction. That reaction is called as a balanced chemical equation. Answer: a reaction every time is it balanced or not? Yes, every time it is balanced. Sir, why every time? Yes, every time. Or otherwise in the reaction some atoms become dead. Is it possible? Some atoms, new atoms will give birth, some atoms give birth to other atoms? No. Whatever the atoms which are participating, the same atoms are there. So then what is the change, sir? Bonding is change. Hydrogen gas, there is a bond between hydrogen and hydrogen. Yes or no? In water, there is a bond between hydrogen and oxygen. The bondings are changing. Ultimately, the atoms are changing. Atoms which are there in the reactant side equal to the atoms are there in the product side. That reaction is called as balanced chemical equation. Then what is unbalanced? That we'll see. First listen here. A balanced chemical equation has number of atoms of each element equal on both sides. Both sides means reactant side and product side. Look at one reaction is given here. Zn plus H2SO4. Zinc plus sulfuric acid gives rise to zinc sulfate plus hydrogen gas. How many zinc here? Only one. Look at on the product side. Only one. Both are same. So zinc is here, zinc is no. Yes sir, you already know that. Hydrogens, how many are there? 2. Here how many? 2 are there. So H2 means here also hydrogen gas, this also hydrogen gas. No. Here H2SO4 it's a new substance. Yes sir, of its own. It is a different substance, right? That's what. How many sulfurs are there? 1 sulfur, 1 sulfur. How many oxygens? 4, 4. Got the clarity? Ultimately, number of atoms on the reactant side are equal to the number of atoms on the product side. Does it mean the compounds are same on the reactants and product side? No. Understood? Then what is the difference? Bondings are different. The atoms which are bonded together to form a new substance, that is different. So in this equation, number of atoms of zinc, hydrogen, sulfur and oxygen are equal on both sides. So this reaction is called as balanced equation. Now what is unbalanced? If the number of atoms of each element and the reactant side is not equal to the number of atoms of each element present in the product, then the chemical reaction is called as unbalanced equation. Same, opposite. If it is equal, balanced. If it is not equal, unbalanced. But what I am saying, every time the reaction is always balanced only. Sir, if every time it is balanced, then why we are writing unbalanced equation? Why we are getting unbalanced equation? The answer is very simple. Students, for example, so look at here reaction, iron reaction with water, H2O produces, we have iron oxide plus hydrogen gas. Okay, iron, how many irons are there? 1. How many irons are there on the product side? 3. Got the clarity? Sir, what about the remaining? That's what. Sometimes students, for example, two students are fighting. One student is coming from 6th class and one student is coming from 7th class. Yes sir, 2 students are fighting. You want to inform to your teacher. How will you inform? Ma'am, students are fighting. You will say like that. Are you mentioning specifically? No. Some teacher will ask, which students are fighting? Ma'am, 7th class and 6th class students are. Arey, okay, which student? Ma'am, the particular name and name. You will say that. Yes or no? If you are specifying how many atoms are participating on the reactant side and how many number of atoms are producing on the product side, then the reaction is balanced. But in general, how do we represent, students? In general, we don't represent how many atoms. Yes or no? We simply represent this is participating, this is reacting, this is producing. Without mentioning the specific number of atoms in their chemical reaction, that reaction is called as unbalanced chemical reaction. What is unbalanced chemical reaction? If you are not mentioning the specific number of atoms of each compound, simply representing the compound, that's it. This is produced, that's it. How many of this? Reacting with how many of this? And producing how many of that? If you mention that is balanced. Simply you are mentioning the formulas, that is unbalanced. Got the clarity? Now answer in the nature, every time the reaction is balanced or unbalanced? Balanced only. Yes or no? We have to balance it. If it is not balanced also, we have to balance it. How to balance it, we'll see. Balancing the chemical reaction. The chemical equation must be written in according to the law of conservation of mass. According to the law of conservation of mass can neither be created nor destroyed in a chemical reaction. To obey this law, the total mass of the elements present in the reactants must be equal to the total mass of elements present in the products. For example, student, this law is given by the scientist Antoine Lavoisier. He states that matter can neither be created nor destroyed. Matter can neither be created nor destroyed. It is simply changing from one form to the another form. That's it. It is changing from one form to the another form. For example, an apple tree is there. Apple is getting produced, a fruit. A new substance, like new number of atoms are produced. No. The tree is taking nutrients from the soil, yes or no? These nutrients are converted for the formation of apple. Apple is a product, that's it. New atoms are getting giving birth here, no, right? Yes or no? You are burning something, for example a book, a wooden log you have burnt. What will happen? That is getting gone, destroyed, all the atoms were gone. No, what is happened? That mass is converted into smoke, some remain as ash. Sir, ultimate, the main point is you cannot destroy matter, you cannot create matter. Matter is simply changing from one form to the another form, one compound to the another compound, that's it. Ultimately, the mass before the reaction and the mass after the reaction same. That is called as law of conservation of mass. In according to this law, we have to balance the reaction, students. Look at the reaction, Fe plus H2 gives rise to Fe3O4 plus H2. For this, first of all, on the left hand side, on the reactant side, how many atoms are there? On the product side, how many atoms are there? You have to write clearly. First of all, find the elements. We have iron element, we have hydrogen element, we have oxygen, iron, hydrogen, oxygen. How many iron are there? Only one. And product side, 3 are there, you can see. How many hydrogens are there in the reactant side? 2. On the product side, 2. Hydrogens are balanced. Oxygens, how many? Only 1. On the product side, 4. Irons and oxygens are not balanced. Yes or no? We have to balance it or not? Simply the compounds are represented, but we need to balance it. How to balance it? First of all, 3 irons are there here. We need to make it 3. Yes sir, how can you make it 3? Can you write number 3 here? Absolutely wrong. Remember carefully. You cannot represent, you cannot change the subscript position in the formula. What is the point? You cannot change the subscript position in the formula. Why? Because that position indicates number of atoms in a molecule, that is fixed. You cannot change it. That is fixed. Then sir, how to make it number 3? The answer is, students, instead of writing 3 here, you can write in front of that element or compound. That's it. Now 3 irons balanced or not, students? Remember, every time while balancing the chemical reaction, you have to write that number, or you have to change the number in front only. You cannot change the formula. H2 is there. You need to add one more hydrogen or oxygen. Can you change in the formula? No. Yes or no? Got the clarity? Right. Next, so irons are balanced. Yes or no? Next, oxygens are how many, students? Here 4. Here how many? Only 1 is there. Then how can you make it 4 on the reactant side? Can you add 4 here? No. H2 for no, right? Then how can you add? Simply this 4 in front of the molecule. This 4 represents hydrogen as well as oxygens also, right? Oxygens balanced. Now how many hydrogens are there? In one molecule 2 atoms are there. Now 4 molecules. 4 into 2, 8 hydrogens. Yes or no? No. Here only 2. Now see. Now see, students. Now look at the reaction. 3Fe plus 4H2O gives rise to Fe3O4 plus 4H2. How many irons? 3. How many hydrogens? 8. How many oxygens? 4. Balanced or not? This reaction is balanced. For unbalanced equation also, we have to make it balanced by simply hit and trial method. By have to check each and every element by adding where you have to add subscript position. No, coefficient number. The number in front of the element or compound you have to change ultimately. Student, this is the reaction after getting balanced. So writing the symbols of physical states substances in the chemical reaction. So students, in the chemical reactions also we can represent physical states, right? Whether it is a solid or a liquid or gas for the reaction also. For example, if it is a gaseous substance, it is represented by small g. You can see if it is a liquid, if a chemical participating in the reaction is a liquid, how to write? Simply L. If it is a solid, we have to write S. If it is aqueous solution, AQ. Aqueous solution means sodium chloride, students. I will show you. Sodium chloride, what is the formula? NaCl. It is participating in the reaction. Is it solid or liquid or gas? It's a solid. Where to represent? Simply here in brackets. Okay. If sodium chloride is added to water, aqua means water, yes or no? Now what happens? It is a solution, right? No need to represent water separately. You can represent simply in brackets, instead of S, in brackets AQ. AQ means already this sodium chloride is dissolved in water. That represents both aqueous solutions. Got the clarity? If it is a liquid, in the brackets I represent L. If it is a solid, S. If it is a gas, G. If it is a solution of water, that means something which is dissolved in water, then you have to represent by AQ, aqueous. Aqua means H2O. So students, I hope you got the clarity. This chapter is very, very important. Chemistry is all about chemical reactions only. Chemistry is all about chemical reactions only. So you have to master the chemical reactions and equations chapter. So what is a reactant, what is a product, where does it happen, how does it happen, everything. So I hope you got the clarity, students. Remaining part we'll discuss in the next video. Thank you, students.